I'm Abirami. I'm going to take a lesson about image enhancement and restoration in the part of frequently domain method sharpening filter. A frequently domining method having two types. Okay, first one is smoothing filter, second one is sharpening filter. Now I'm going to take about the sharpening method. Okay, first of all, image processing, I already says that image processing in the frequency domain having two types, image smoothing and image sharpening. Okay, sharpening in frequency domain. What is mean by sharpening? Edges and fine detail in images are associated with high frequency components. High frequency components are called high pass filters. Only pass the high frequency, drop the low ones. High pass frequency or precisely the reverse of low pass filter, which means the frequency having high means it is a high pass filter and it will become low, that the reverse of high pass filter is the low pass filter. Okay, next one, types of sharpening filters. There are three types of sharpening filters. Okay, first one is ideal high pass filters, second one is Butterworth high pass filters, third one is Gaussian high pass filters. Okay, each of these filters have two types. Okay, ideal high pass filter, ideal low pass filters, Butterworth high pass filter, Butterworth low pass filter, Gaussian high pass filter and a Gaussian low pass filter. Okay, okay, then ideal high pass filter. What is mean by ideal high pass filter means in the field of image processing, ideal high pass filter, IHPF means ideal high pass filter, is used for image sharpening. Why do we do sharpening? To get an image better than the taken image from our mobile phones or cameras anyway in the frequency domain. Now, image sharpening is a technique, one of the technique to enhance the fine detail and highlighted the edge in a detailed image. Okay, this is why we using ideal high pass filter. It removes low frequency components from an image and preserves high frequency components. Now you have to know that why it is named as ideal high pass filter. What is the difference between ideal high pass filter and ideal low pass filter means the it removes low frequency components means it is a ideal high pass filter. It removes high frequency means it is a low pass filter. Okay, now you have to see this. It removes low frequency components of an image. This is known as it removes an low frequency. It removes low frequency component, then it is known as the high pass filter. Okay, now next, ideal high pass filter is the reverse operation of the ideal low pass filter. It is the opponent, it is the opposite one of low pass filter. Okay, it can be determined using the following relation. Okay, now I have to say that we have to use d naught for define. It is a positive component IPHF. IHPF means ideal high pass filter. Okay, passes all the frequency outside a circle of radius, that is known as d naught. You have to remember that d naught because it will help to calculate the formula for this ideal high pass filter. Thus, D naught is the transition point between h of uv is equal to 1 and h of u comma v is equal to 0. So, this is termed as cutoff frequency. You have to note this, h of u comma v is equal to 1 and h of u comma v is equal to 0. This is known as cutoff frequency. This is more important, note this point. Then d of u comma v is a Euclidean distance and from any point u comma v to the origin. This is the formula for the next. Okay, Now I have to write the formula for this equation for this ideal high pass filter. Okay, H of u comma v, H of u comma v of equal to 0 1 d of u comma v is equal to greater than or equal to d naught. I have to say is that d naught. Okay, you have to remember that d naught because it will be helpful to derive these equations. And 0 means d of u comma v I already says that d of u comma v is a equilibrium distance. Okay, this is the one of the basic formula for this ideal high pass filter. Okay, now this is the input image that I have to given for the transition. Okay, this image will be changed into this image. Okay, you have to uh, see that the transition happening using ideal high pass filter. Okay, now we have to going to see about ideal low pass filter in image processing. In the field of image processing, ideal low pass filter is used for image smoothing in the frequency domain. It removes, I already says that if the low frequency is removed, low frequency noise is removed, is high pass filtering, and high frequency noise remove means low pass filtering. Now you have to see this formula. You have to see this formula. This is the formula for ideal high pass low pass filtering. Okay, now next you have to see this image. This is the input image for ideal low pass filtering. This is the output image for ideal low pass filtering. Now I am going to give the approach. This is the approach if you are using ideal low pass filtering or ideal high pass filtering using MATLAB. You have to use this as commands for your projects. Okay, first of all you have to give the input and saving the size of the input image in pixels. Every image is combined upon a pixels. You are already known that. Now get the Fourier transform from the input image. I have to tell about Fourier transform in the next slide. Okay, the assign the cutoff frequency. The cutoff frequency is what the is get we have to get that from the formula h of u comma v. Okay, designing filter, ideal high pass filter, convolution between the Fourier transformed input image and the filtering mask. Take inverse Fourier transform of the convert image, display the resultant image output. Okay, now we have to see about one simple thing, how we are going to understand the ideal high pass filter and ideal low pass filtering. Okay, ideal low pass filtering, which means if I have the only one inside the circle, in center of the circle. Okay, center of this zeros, when one is placed inside, the zero is placed outside, we got a blurred image. You have to understand that when one is placed inside and 0 is placed outside, we got a blurred image, which means ideal low pass filter. Now As we increase the size of one, blurring would be increased and the edge content would be reduced. That is called ideal high pass filtering. Okay. Next, I will detailedly explain about D naught. When 0 is placed inside, we get edges. 0 is placed inside means we get edges, which gives us a sketched image. Okay, an ideal low pass filter in frequency domain is given. The ideal low pass filter can be graphically represented as this is the one of the image that is shown that this is D naught. It is placed here D naught 0 1 H. This will show you the H of U comma V, that formula. Okay, now I am going to show you the how the domain frequency domain will be applied and the filter is applied over the images. Okay, here you have to see the simple sample image. Okay, now image in frequency domain. If the image was in frequency domain, it will shows this, and after filter one we have to apply the filter over this, then the resultant image will be shown by this. Okay, next, Butterworth high pass filters. The Butterworth high pass filter is a signal processing filter designed to have a frequency response as a flat as possible in the pass band. It is also referred as maximally flat magnitude filter. In the field of image processing, Butterworth high pass filter is used for image sharpening in the image frequency domain. Okay, image sharpening is a technique to enhance the fine detail and highlight the edges in a digital image. It removes low frequency components from an image. You have to note this, it removes low frequency components from an image and preserves high frequency components. Okay, this is the high pass filters. This is same thing as we seen before, ideal high pass filter. It removes low frequency components, that is ideal high pass filter. This is also happening here, that is a Butterworth high pass filter. Okay, in this image you have to see that the result of Butterworth high pass filter is much smoother than ideal high pass filter. Here the boundaries are much less distorted even for the smallest value of cutoff frequency. You have to notice that why Butterworth high pass filter is used. It is more smoother than ideal high pass filter. Then only we have to use the Butterworth high pass filter uses. These are the same approaches that we have seen previously in ideal high pass filter, that if you are using these techniques using MATLAB, you have to use these approaches to fulfill the process. Okay, and next, Butterworth low pass filter. What we have to Butterworth high pass filter means we have to remove the low frequency in Butterworth high pass filter. Butterworth high pass filter. Now we have to remove. It removes high frequency. It removes high frequency noise from the digital image and preserves low frequency components. The transfer function of Butterworth low pass filter. This is the basic thing of Butterworth high pass filter and Butterworth low pass filter. Next, this is the input image of Butterworth filter and Butterworth low pass filter. Okay, next, Gaussian low pass filter. The concept of filtering and loss pass remains the same, but only the transition becomes different and becomes more smooth. Okay, note here you have to note that D naught, the smooth curve is transition due to which at each point the value of D naught can be exactly defined. And the Gaussian high pass filter has the same concept of ideal high pass filter, but again the transition more smooth as compared to the ideal one. This is the reason why are using these type of filter, why we are using ideal high pass filter, Butterworth high pass filter, Gaussian high pass filter, or the are using for the same reason. You have to see here Gaussian low pass and Gaussian high pass filter minimize the problem that occur in ideal low pass and ideal high pass filter. Then why we are using the filter for better experiences? Okay, the problem is known as ringing effect. The problem that occurs in ideal high pass filter is being a the problem happening in that filter is a ringing effect. Okay. um, okay, next, this is the representation of ideal low pass filter. Now at the exact point of d naught, you cannot tell that value would be 0 or 1. You have not to know that it is a 0 or 1, due to which the ringing effect appears at the point. You are unable to get the point 0 or 1. This is due to which that is known as ringing effect. So in order to reduce the effect that appears is ideal low pass filter, ideal high pass filter. The following Gaussian low pass filter and Gaussian high pass filter is introduced. You have to understand that you cannot tell the value 0 or 1. That is, some effect is happen in that place, that is known as ringing effect in ideal high pass filter or low pass filter. To rectify that problems, the new effect will be introduced, that is Gaussian high pass filter and Gaussian low pass filter. Okay, and I have to say already that I am going to say about Fourier transformation. Okay, Fourier transform will reflect the frequency of periodic parts of the image. By applying the inverse Fourier transformation, the undesired or unwanted frequencies are removed, and this is called masking or filtering. Then I have to give these three images: original image and Gaussian high pass filtering and Gaussian low pass filtering. Now this is the original image that we give Gaussian high pass filter, frequency emphasize filtering, histogram equalization. These all give you a better experience than existing ones. So this is why we are using the filtering methods. Okay. Next, I have to going to differentiate the two types of filters: low pass filters and high pass filter. It is used Low pass filter is used for smoothing the images, and high pass filter is using to shortening the images. It attenuates the high frequency, it attenuates the low frequency. Low frequency is preserved in it, high frequency is preserved in it. It allows the frequency below cutoff frequency to pass through. It allows the frequency above cutoff frequency to pass through it. It consists of resistors that followed by capacitor. It consists of capacitors that followed by resistors. It helps in removal of aliasing effect. It helps in removal of noise. And this is the formula of low pass filtering. This is the formula of high pass filtering. Then how we have to use these formulas. Uh, in case any doubts, comment me on my comment box. Thank you for this cooperation.